Newton's laws of motion. As long as we're talking about one of the greatest scientists who ever lived, let's move on to Newton's other famous laws. His three laws of motion form an essential component of modern physics. And like many scientific laws, they're rather elegant in their simplicity. Law of inertia. The first of the three laws states that an object in motion stays in motion unless acted upon by an outside force. For a ball rolling across the floor, that outside force could be the friction between the ball and the floor, or it could be the toddler that kicks the ball in another direction. Law of acceleration. The second law establishes a connection between an object's mass, m, and its acceleration, a, in the form of the equation F equals ma. F represents force, measured in newtons. It's also a vector, meaning it has a directional component. In mathematical terms, F equals ma, where F is the force applied, m is the mass of the object, and a is its acceleration. The acceleration of an object is directly proportional to the force applied to it and inversely proportional to its mass. The third law is rather pithy and should be familiar to you. For every action, there is an equal and opposite reaction. That is, for every force applied to an object or surface, that object pushes back with equal force. For every action, there is an equal and opposite reaction. In other words, if object A exerts a force on object B, then object B exerts an equal and opposite force on object A. These laws describe the behavior of objects in motion and have many practical applications in our daily lives. For example, the first law explains why it is difficult to push a heavy object that is at rest, and the third law explains why rockets are able to launch into space.